Myself, Mr.Shivappa M Metagar, working as assistant professor in computer science and engineering department at WIT Institute of Technology, Solapur. Now I welcome to the session on simultaneous open and close. So in the previous video, we have discussed about this is a part of the TCP straight transition diagram. So in the previous 2 videos or 3 videos, we have discussed about the part of this video, and now we are continue the remaining part topic, that is simultaneous open and close in the state transition diagram. Learning outcome: at the end of this session, students will be able to describe the concept of simultaneous open and closes in state transition diagram of TCP. Content about simultaneous open, about simultaneous closes, diagram. Now let us see about the simultaneous open. So simultaneous, before going to start the concept, we have to know what is simultaneous. It means at a time, at the same time, if two process can take place, that we can call it as simultaneously. It is at a time more than 2 processes will start. Okay, in a simultaneous open, both applications issues active open. Here both applications, it means 2 applications issues active opens. This is a rare situation in which there is no client or server. Communication is between 2 peers that know their local port numbers. Simultaneously, client and server, they can start communicating with each other. So this case is allowed by TCP, the transmission control protocol, but it is unlikely to happen because both ends needs to send SYN segment to each other, and the segments are in transit simultaneously. Okay, this means that the 2 applications must issues active open almost at the same time. At the same time, 2 users can start sending the request or start receiving the response from the server side. So below figure can shows that the connection establishment phases of this scenario, both TCPs go through the segment sent, synchronization sent and synchronization received states before going to establish the state. Now let us see the diagram. This is a block diagram of simultaneous open. Here it can contain 2 parts. First one is this process at the transport layer of the client side. That's a transport layer at the server side. So the client and server, they can they want to communicate with each other. It means how they can send the data and receive the data with the help of diagram. Now let us see here a process, that is transport layer user of the server's client side, they can open the active open the connection. So before here the closed is there, here closed is there, they have to open the active open at the client side. So after opening the active open, he can send the synchronization to the server side. The server can again, it can open the active open, so it can send the synchronization plus acknowledgement. So here this one, the client side first synchronization they have sent, and again they have sent the second synchronization also. Synchronization plus acknowledgement is there. So here the server can send the synchronization simultaneously to the server. The client can send this synchronization plus acknowledgement to this synchronization. He can reply to the server side. Again he can send the, after receiving the client side server side synchronization, again he can reply to the server synchronization plus ACK is it synchronization plus acknowledgement to the server side. Here both client as well as server, they can simultaneously open the connection. After opening the connection, both the users can start sending the data and receiving the data. They have both the users simultaneously, they have sent the acknowledgement, and after sending the acknowledgement, they have get the simultaneous acknowledgement to the respective sides. So after that, here initially it will be there in the ideal state or in the closed state. So they have to open active and then they can start communication. Here is also connection established phase is there. Here is also connection establishment phase is there. Okay, this is a block diagram of simultaneous open. Okay, a closed loop shows that both the process act as a client and server. 2 synchronization plus ACK segments, acknowledge the segment synchronization segments and open the connection in the server side. Whatever we have discussed in the above diagram, the concept is there here. Note that the connection establishment involves four-way handshaking. Four-way handshaking is a three. In generally, we have to use a three-way handshaking. It means first client can send the request, and after sending the request, he can get the reply. After that, again he can send the acknowledgement to the reply. That three steps we can call it in three-way handshaking. But here we have connection establishment phase involves a four-way handshaking. It means more than two users simultaneously they can open the connection. So one more step extra we have to use. That for that purpose, this one we can call it as four-way handshaking. Okay, the data transfer and the connection termination phases are the same as previous example whatever we have discussed in the previous video, and are not shown in this figure whatever the parts we have discussed in the previous diagram. Okay, now it is a break time, that is the think and write. It can contains one question, that is in modern implementation of transmission control protocol, retransmission occurs if the transmission timer expires or dash dash duplicates acknowledgement segments have arrived. There are four options are there. First one is a 1, second one is a 2, third one is 3, fourth one is none of the above. Okay, now we can pause the video for a second and then answer the above question. Okay, let's see the answer for this question. Here, in modern implementation of TCP, transmission occurs if the transmission time expires or in the duplicate have arrived in 3 duplicates acknowledgement segments have arrived. Okay, the answer, correct answer is 3. 1, 2, 3, none of the above is a correct answer is in 3. Okay. Now you can go to the next bit, the next part of this video, that is simultaneous closes. Okay, simultaneous close, another uncommon but possible in this scenario, that is in the state transition diagram scenario. Transitions is the simultaneous close. This is a block diagram of state transition diagram of simultaneous closes. If two users, that is client and server, are communicating with each other, there are a number of segments they are transmitting, the number of packets they are transmitting, so they have to fix the timing and all those things. Then if they don't want to communicate with each other, they have to go for the close function or closed connection. Now here this block diagram can contain the process, and then transport layer of the client, transport layer of the server, process. Here first they can open the active open, here in server side also they have to open the active open. So after opening the active open, so they can go for the closing state, that is fin wait 1, fin wait 1. It means that these are different steps or bits we have already discussed in the first video. What is fin? That is final termination of wait 1, wait 2, wait 3, like this we have discussed, that you have to. And then after this one we have to go for the closing phase. Here the time and wait is there, here also time and wait is there. It means here we have to fix the timer, that is to maximum segment limit timer we have to use, that is to MSL. Here also we have to fix the timer. After fixing the timer, if before transmitting any data, both the users they can use the timers, then they can, after fixing that, they have to send the data. So first the client can send the data by using the active open in the client side. So they can fin, they can send it to the server side. Again the server can open the active open, he can receive the acknowledgement request from the fin request, that is termination request from the client. So again the fin wait 1, he can send the acknowledgement to the server side. So until that 2 MSL timer is there, and then again the server can send the acknowledgement to the client side. The client again he can send the acknowledgement to the termination, that about this one. So again he can send the termination, here they can send the acknowledgement. Both the users, if they don't want to communicate with each other, so that time we have to go for the termination, that is simultaneous close part in the transition diagram. So they have to fix the timing, based on the timing also we have to fix, and then they can close the connection in both the client side as well as server side. Okay, so this is a theoretical part is there. In this situation, both the end issues an active open, that is active closes, both TCPs go to the fin wait 1 state and fin segment. It means fin, it means these are different states are there, that is final termination. Okay, wait 1 states and send a fin segment that are in the transit simultaneously. Okay, after receiving the fin segment, each end goes to the closing state and sends an SCK segment. That is SCK segment, it means acknowledgement segment to the receiver side. The closing state takes place of the fin wait 2 or close wait in a common scenarios. So in the second video we have discussed about the what are the different common scenarios we have to use in a client side as well as server side. Okay, after receiving the SCK segment, each ends moves to the time wait state. Okay, note that this duration is required for both ends because each end has sent an acknowledgement that may get lost in the server side as well as in the client side also. Okay, we have eliminated the connection establishment and data transfer phase in the figure. Why? Because simultaneously open is there, for that we have eliminated the part of this one. Okay, this is a reference I have used for preparing the above PPT. Thank you.